Alright, this tutorial is on recursive functions. Unfortunately, I will not be explaining you the whole detail and giving you the advanced functions that you will be using. It's beyond the scope of this beginner course, but a recursive function is basically a function that calls itself, and it's used very commonly in programming. And a really good example is the one on the screen that you're seeing right now. It's a factorial. So how do we define a factorial equation? So we would say, for example, if it's 3 factorial, we say, well, 3 factorial is equal to 2 times 1 factorial. Or if it was, sorry, it was supposed to be 2, 3. If it was 4, we would say, well, 4 is equal to 4 times 3 factorial, and that's how it works. So let me remove that and explain to you how we will define this. This is how we do this by using factorial, by using recursive functions. So first of all, we define a general case. So this is our general case, all right? General. Then we define a base case, all right? What is our base case? Base case is the one that's going to stop the recursion, because recursion is this. You have this factorial function and you're going to call it again inside of the function. So the function will be calling itself again and again until it reaches this base function, all right? It is very important. If you don't have any base function or, sorry, base condition, or your function doesn't reach this base function or base condition, you're gonna have some problems. So make sure that you have this guy, all right? You need to have this guy, otherwise your well, recursion will be infinite. Of course, at some point, Matlab will stop the equation, but unfortunately, your recursive function will not work and it will cause some problems, maybe crash your Matlab. All right, so how does it work? It works this way. So I'm going to explain it to you in 3's example. So in 3, we make 3 factorial equal to 3 times 2 factorial. So what happens here? 2 factorial, again, goes back here and runs the whole thing again, all right? The whole thing. It is like this, 2 factorial times 1 factorial, right? Then function runs again for 1, and it sees, oh, 1 factorial has to be equal to 1. I think it's a good time to stop. Then the function goes back, all right? Function says, well, this is 1, then this is equal to 2. Then this function will go back and say, well, this function is equal to 2, then this means this thing is equal to 6. Let me show you this and another example in 4 to enhance your understanding, I would say. All right. You must have realized that I love using colors, a lot of different colors here. Okay, this color is good. So let's use it. We have 4 factorial equals 4 times 3 factorial, all right? So 3 factorial is equal to what? 3 times 2 factorial, all right? 2 factorial goes to 2 times, I'm sorry, I always make this mistake. Let me clean this up. All right, 2 times 1 factorial, and we get into an if statement which says if 1 factorial is equal to 1, do not recurse. Well, the recurse is not a real word, do not reiterate. Then going back starts, all right? This is equal to 2. This is equal to 6. And this is equal to what? 24. And the result is going to be 24. So let me show you the real function. Okay, the real function is here. We have one output, which is result. We have a variable here, which is called number. So you're going to insert your number. Could be 5, could be 3, could be anything. And this is our function, factorial. And you see we have called it here. All right, factorial is here. So the case is this. If number is equal to 1, which is the base case, let me write it down here, base case, result is going to be 1. Stop iterating. When the result is going to be 1, this thing will happen. This thing will start happening, all right, going down and calculating everything out. Else, get in and make the result equal to number times factorial, which is where our recursion works, factorial number minus 1. So this is where the function updates itself. It's always decrementing the function, decrementing the value of the function. Then it goes back until it reaches 1. When it reaches 1, the result is 1. Once the result is 1, it goes back to the result and outputs the value. So let's do that. Factorial, well, let me actually make it equal to a variable, result. It actually doesn't matter because it's a local scope. Result is equal to what? Factorial, and I'm really going to say 10. I've never seen 10 is factorial. All right, that's a big number, 3,600,000, 28,800. All right, that's a really big number. So you can try in a different forms. For example, you can, unfortunately there's no binary trees here, but it's also useful when you're searching in the binary tree or inserting some values. But that's all about it. By the way, I forgot to mention something, a global variable. We're going to use it in some projects. This is how you define global variable. You say global, let's say, G is equal to, let's say, 9.81. All right, that's how you define it. All right, thank you for watching. I will see you on another tutorial.